record button. So I do record every session, and that recording after the class is over, I convert it into a YouTube video, and then it gets posted in the announcements. So the recording built as is too big. We can't keep them all, which is why it gets converted. So later, if you need to come back and double check something or whatever, you will have access to the video in the announcements. So before we get started, thank you for showing up today. Day one, I like to give you a visual. Ooh, there it is. Hi. You already all know what I look like because I sent you intro videos last week. But this is where I do all of the classes. So I'm in my office. I've got, there he is, Stitch in the background, just so that you kind of have an idea of what I'm doing. I'm sitting in front of my computer, and it's pretty great. Okay, so I don't keep the camera on because it's not about you seeing me. It's, oh, I hit the wrong button. It's about you being able to, see the math, ask questions about the math and that kind of thing. So does anybody have any questions about anything before I start yammering on about everything on my list? Because first and foremost, these sessions are about you and what you need, if you need anything, I guess. So, all right, we do have the chat box. So throughout class, I do have my chat box open. I monitor that throughout the class. So you can type comments, suggestions, questions in there, and I will monitor those as we go. Of course, you can also talk. You have the power to control your microphone, and we'll go from there. So, okay. Generally, every Wednesday, we're going to sit down and we're going to talk about, math. Today, we're covering sections 1 through 5, which seems like a lot, but it's not too bad. Your first assignments are due on Friday. Many of you have already started. You've turned a lot of things in. I read a lot of very interesting discussion boards this morning. I tried to comment on many of those. So thank you for being ahead of things and going from there. All right, so let's go ahead and talk about the class itself. Now, I'm not going to talk about details because I sent those all in a video. So if you did not watch my intro videos I sent last week, please go back and do that. But I want to hit some highlights, things that are very, very important. First and foremost, I want to talk about the announcements. I post a lot of things in the announcements. I sent a lot of emails in the first week. Hey, Isabel, can you mute yourself, please? Taggart, can you mute yourself, please?
Yeah. Oh, yeah.
Whoa, that was some good feedback there. Okay, excellent. Thank you. Feel free again to unmute yourself anytime you want to talk. But the announcements. So I sent a lot of emails at the beginning of the semester because I'm not sure how familiar people are with the course. But now that we are in the course and we're rolling with it, pretty much all of my communication will come through the announcements. If you email me, I will obviously email you back. But anything that I'm going to post to the class, I will post in the announcements. So you see the top announcement here is Section 2 WebWork 18 and 19. So if you haven't finished Section 2 WebWork yet, 18 and 19 can be a little bit of a beast. And I've got help videos here. Because I know that sometimes I'm not available when you're working on things. And so help videos can be there for you whenever you need them. So those are there. Obviously, if you watch the videos and you're still lost, shoot me an email. We will troubleshoot and figure out what you don't get. All right. So be checking your announcements. They should pop up on your homepage at the top. But I mean, I will post help videos for all of the Excel assignments, all of the projects, all of this stuff. So make sure you're checking the announcements for those kind of helpful hints because I will be posting a lot of things there. The syllabus, if you have not read through the syllabus, please do that. Here's my information. I'm on campus Monday, Tuesdays, and Wednesdays on the Warsaw campus if you need to come in and see me. But I am available way more than just those times. So if you need me for something, you just have to shoot me an email, send me, carrier pigeon, shoot me a phone call, whatever. If you say, hey, this day, this time, I can either meet you here. I live in Fort Wayne. We can set up a go-to meeting at 7 o'clock at night if I'm not doing anything. So all you have to do is ask, and I'm willing to help you, right? Because the better you do, the easier my life is. So I want you to be successful. Okay, but I want you to read through this because there's a lot of information in there. You know, how this class is graded, blah, 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 blah. One thing I do want to talk about are the exams. This class has 3 exams, and they are proctored, meaning you have to be in these, you have to have a proctor with you when you're taking the exams. The easiest way to do that is to come to an Ivy Tech campus anywhere in the state. If you are taking this, your exam at an Ivy Tech campus, great. I don't really need to hear from you. If you cannot make it to campus, right? I have a student in my other class lives in Arizona. Obviously, she's not taking classes at an Ivy Tech campus. You just need to reach out to me and we will figure out how to fix this. So if you live near a different college, we probably can make that work. Some public libraries have proctoring sites, or you can use ProctorU. So ProctorU is a testing service, and you can take your test at home in front of your computer. To do that, you have to have a webcam, because we have to set this all up through ProctorU. So if you're going to use ProctorU, I need to know that like this week because it takes a bit to get all that going. And it will cost you like $20 or $25 per exam. So if you're taking it at home and all 3 of them, it could cost you like $75 this semester to take all of those exams. But for some people, that's, your only option. But those payments go directly to ProctorU. It's not an Ivy Tech thing. That's an outside company that helps us with this type of a thing. So if you have other questions about how to take those exams, what to do with that, please send me an email. I will be posting an announcement. It's probably not happening today. It'll be either this week, beginning of next week, on how to schedule your exams through Ivy Learn if you are taking it at an Ivy Tech location. But you can read that announcement when it comes out and take care of it then. So please do, check your emails, check your announcements, because I'm going to be communicating a lot here in the first couple weeks, okay, about those types of things. Anything else? Blah, blah, blah. There you go. Here's all of your assignments for the class. It's a lot. There's a lot of stuff in this class. So it's just really important that that you keep up on things as we go through. Okay. Again, feel free to interrupt me with questions, comments, concerns, suggestions, cuss words, anything. The modules I'm not going to spend too much time on, but one thing that I want to highlight. Here in Module 1, you see these 2 things called videos. I'm just going to click on Section 1 for fun. You all should have gotten a workbook in the mail, and these videos go through the workbook. So this would be like you sitting in a classroom working through the material with an instructor. Some of them are very short, some of them are 10, 12 minutes. It just depends on the video. But I do recommend you watch these as you go through things. If you want to look through your workbook and say, oh, I remember how to do this, I've done this before, then that's great. But many people have not dealt with age dependency ratios, and that's going to be an important video to watch first. So make sure that you recognize in all of your modules, they have these video pages that go with your workbook. So they are there, along with all of the rest of their other assignments. Aurora, question, you can use any calculator you want on the exam. Yeah, it doesn't matter which kind. Anything is good. Yep. Okay, so we'll go through. So basically we're doing modules 1 and 2 this week. You're welcome. Module 1 is due kind of like on Friday. Module 2 is due Monday. So you don't have a lot of downtime in this class this summer because we have a lot of stuff to get through. So WebWork, assignments, WebWork, discussions, quizzes. Hopefully you're all in WebWork by now. If you're not, get there because your first assignment I think is due on Friday, and you run out of time because it's Wednesday. A lot of you have done discussion boards already. High five. Good work. Good work. Any questions about the course itself in Ivy Learn? What do you use to log into WebWorks? Tiffany, did you watch the video I sent last week? Were you in this class last week? Your name does not look familiar to me. Because I talk about how you log into WebWork in that video, which is the purpose of me sending them. You're not on my list. There you are. Yeah, you are. You're in there. You're on my list, which means I have created your account. First letter of your first name, last name is how you log into WebWork. But if you go back into your email, there should be a video about WebWork so that you can get your full introduction there. And that's one thing I want to point out. If you look to the left of my screen, I'm not going to click on it because it's a FERPA violation. But you see the inbox with a 91 there on the left side of my screen over here. If you don't have your notifications set up, when I send emails, I send them through Ivy Learn. And that's where they go for you. So I have mine set up that if you send me a message through Ivy Learn, it goes to my email. If you don't have that set up, your emails from me might be sitting in that inbox and you're missing some information. So you always want to also double check that inbox to make sure you're getting the right information. Okay. But hopefully that will take it out. So Tiffany, your WebWork would be T Marsh, and that is your username and your password. Okay, so Caitlin's question is a fabulous question. Can we take the tests early? Can you work ahead on things? Absolutely. Everything is open right now. You can work as fast as you want, get through as much as you want. You can take your tests as early as you want. You can finish this class in 3 weeks if you want. As long as you do all the work, that's fine. I have not submitted the test sheets to the proctoring center yet here at Ivy Tech, which means you can't take test 1 yet because I haven't done that paperwork. But that is on my list of things to do tomorrow. So it should be done this week. But yes, you totally can do things early. I don't block things off and make you wait. You work at your pace. So we have due dates. You have to do things before the due date, but you can totally work ahead. Absolutely. Yeah. Yep. Oh, no problem. And if you email me in week 2 about a question in module 9, I'm not going to say, you're working ahead, that's bad. Heck no. I'm all about helping you where you are. So you let me know what you need, we'll go from there. Good. Okay, so that's the inbox. Double check those. If you don't think you've been getting my emails, check your inbox. I bet they're sitting in there. The calendar feature, I don't know how much you guys know about the Ivy Learn calendar, but it's pretty fabulous. Excuse me. My computer is a little slow, but other than that, we're doing okay. So I'm teaching 2 classes this summer. They're both 123 and they're on the same schedule. So you can see I don't know how many classes y'all are taking, but they should have different colors, and you can click on, other colors things. None of these have due dates, but anyway, it'll show you what's coming. So if you're like, okay, I haven't done quiz 1 yet. So if you are looking at your calendar and you say, okay, I need to go take quiz 1, if you click on it and then you click on the name, it'll take you directly back into the class, right to the quiz. Now I'm the instructor, so it looks different, but yours would say take quiz and you can go straight from there. So that is, a bonus of the calendar feature as well. So, okay, I want to spend just 2 seconds on WebWork. Many of you have already, started this, but one thing I wanted to point out, you do have videos these are packet videos. They go with the workbook that you got in the mail. Within questions, I don't think section 2 has any help videos, but I know 17 does. When you get to a problem, if you get it wrong 3 times, many of them have hint videos that will pop up. So these are just a video example. They're YouTube videos, whatever. They're made by me, but they will help you kind of work through the problem. If you get to a problem that doesn't have a hint video, you've gotten it wrong 3 times and there's no video that shows up, shoot me an email. Some videos I have made for WebWork problems, they just have never been loaded in by our WebWork person. So I can get those and send them to you, or, make a new video or whatever. All you got to do is ask. So there's that too. So one other thing in WebWork, at the very bottom of the WebWork, you see video lessons 080. These are units, Unit 1, Unit 2, Unit 3. And so if you are in Section 2 and you need more work with age dependencies, you can go in and just watch age dependency ratios. It's another video about those types of ratios. So anything that you might be having difficulty with, more than likely there's an additional video about it in that 080 section. And there are pages that go with them in the back of your packet. So it's like, I don't know what page number it is, but there's a blue piece of paper at somewhere, and behind that is all these additional practice pages in your workbook, and these videos go with those. So it's just another resource. If you need extra help and you don't like to reach out, I want to make sure you know where all of your resources are. Of course, I am always available. Okay. I'm doing a decent job so far this year of keeping up on emails. You guys are challenging me, which is not a bad thing. So, keep them coming. Questions are good. So earlier, Tiffany, I'm not picking on you, but you know how Tiffany asked about WebWork, and my first question was, did you watch that video? If I have posted a video or I have sent a video, or if I know there's a video in there, that will always be my first question. Because if you've watched the video and you still don't get it, that tells me, okay, we've got a different issue then, maybe you just rounded wrong. And so if you've watched the video and you're still not getting it right, then I'm like, okay, now I need to go and I need to dig a little deeper. It's no longer maybe a surface problem. Now we've got to look and see why we're not understanding. So when I ask you via email, did you watch the video? I'm not attacking you. I'm not accusing you of anything. I'm trying to see where we are in terms of understanding. Okay, so that's why I do that. And it's okay if you respond and say, no, I didn't see the video, or that, whatever. I'm never going to be mad at you whether you watched or not. It's just a conversation piece. And I will do that a lot. So consider yourself warned. Yeah, no worries, no worries. It's week 1. We're all still trying to figure this out. We're all still trying to figure out where everything is, how everybody works. My main goal is to have as many of you pass this class as possible, because then I look good. So it's selfish of me, but it works for you because then you get all the help you need, right? It's a win-win for everybody. Okay, so that's WebWork. If you're not in yet, so Tiffany, you're going to do this after class. Anybody else who's not in WebWork yet, as soon as class is over, try to get in, right? Use your first letter of your first name and your last name. Get into WebWork just to make sure you can get in, because I hand put everybody's names in. So if I spell something wrong, then we're toast. Okay, so, or if you've gotten married since at some point and your name didn't change in here, you're using one name and I'm using another name, that's where an email comes in. Okay? Okay, great. I think that's all I have to say about Ivy Learn. Who's got questions? Anybody? Anybody? I don't want to spend too much time on that. I sent the videos out to kind of give you an overarching piece there, but I wanted to at least touch on certain things to make sure we're all on the same page. And again, there are no stupid questions, so shoot me emails if you have questions. And we want to make sure that, especially we get off on the right foot. Once you get behind, it's a little hard to catch up, and I don't accept late work. So you have, due dates are due dates for a reason. Trying to keep you on pace, keep you working. So, it's Wednesday. First stuff is due on Friday. We want to make sure we're moving along. So, okay, great. Oh my gosh. So when you, Haley, that's funny. When you registered for the Go to training, I'm guessing you hit a button, right? Because the R and the T are next to each other. So you kind of gave yourself the wrong name, which, I'm sorry, that's funny. If it doesn't bother you, it doesn't bother me. I'm guessing there's a way that you could go in to go, like when you register, maybe. I don't know. Does it bother you that you have the wrong name? It doesn't. I usually just pay attention to first names. I don't really pay attention to last names, but that's funny. Okay, great. Then you can just have, can be your alter ego, right? You have your second personality here for the class. That's, that could be fun. It's like your math personality. All right, so let's go ahead and jump in. So one thing that I have a rule, I'm not going to do any problems that you can see outside of this session, meaning your workbook that you have, I will not do any problems from the workbook here in this class, because you have the workbook and you have all of the videos that go through every problem in the workbook. I don't need to do them again. Then you see them twice. That doesn't help you. So all of the problems that we work through in these PowerPoint sessions here on class, I call them Becky Specials, meaning I made them all up based off of the content. So if you watch the videos that go with your packet and then you come to class and you get these extra ones and then you do your homework, you're going to get the concepts because you're going to really practice it quite a bit. And that's a good thing. That's a good thing. So, all right, let's go ahead and start. All right, so we've talked about most of this stuff already. We've talked about proctored exams. I will be posting something in the next day or two about exams again, so make sure you're reading the announcements. Expectations are kind of easy. I expect you to do your work. I expect you to do your work on time. I expect you to either show up for this session or watch the recording, one or the other. I know that life happens. There's going to be some Wednesdays that don't work for you. That's fine. That's why I record them and I post them. So watch them on your own time. That is an expectation. And in return, you can expect me to answer your emails, be available when you need me, help you in any way possible, all of those kind of things. So it's kind of a two-way street. You do your part, I'll do my part, and we'll kind of be successful from there. Okay, so this week we are doing 2 modules. So we're going to start here. This PowerPoint is just module 1. And then we will move on to module 2. So your orientation for WebWork, which I also sent an email about, number 6. And then you've got WebWork 2, which I posted the 2 videos in the announcements. So make sure you're seeing all of that. Whew. Sometimes it's hard to talk to a computer screen. In case any of you have never tried it, it's exhausting. All right, so we're about ready to jump in. Last minute for any other random questions that do not deal with mathematics. All right, interrupt me later if you need to. So quantitative reasoning in section 1, I'm not going to spend much time with this. The only thing I'm really going to say is quantitative means numbers. Reasoning means thinking. Reasoning, that's kind of not good to use that same word. Using logic. So we're thinking through numbers. We're going to talk about numbers. We're going to write sentences in this class. You're going to have to tell me what your answer means. You have to justify why your answer is right. And that's where the reasoning piece comes in. We're no longer just finding the answer is 4 and circling it and calling it a day. What does that 4 mean? Is it a logical answer? Why is it right? Basically, it just shows that you understand what's going on. And this course, one reason I actually like this course, it's math, and I'm a math geek, so that's one thing, but also it's real world math. We're going to do a lot of different things that you will actually see in your life at some point. Not all of you will see all of it in your life, but I mean, we do a financial section. You're all going to deal with financials because you're humans. So that's a positive too. So, okay. So that's section 1 in a nutshell. I mean, obviously there's more to it, but we are on a limited amount of time. So section 2, ratios. Tell me everything you know about ratios. And you can do it verbally or you can do it in the chat box. But what do you know about ratios? Tell me. We don't know anything about. Most of you have done, well, I shouldn't say most. A few of you have done all of that, the homework for that, and you can't tell me anything? That makes me a little bit nervous, the fact that you did the homework and you can't tell me anything. Okay, let's see. Ratios, they compare. They do, Brittany, they do. Yes. So ratios are a comparison of 2 values. We can write them, back in the day, you probably talked about ratios, with the word to. Caitlin, they can be part to wholes. We can also have part to part. There we go. Now we're getting there. We can use the colon. We can use a fraction. Yes, great. Oh, you're doing this at work. High five to you. Good job. All right, so these 2 here that I'm putting in a box, they're correct in terms of ratios, but they're not very practical in actually being able to use them. Now, fractions, on the other hand, that is something we can use. So fractions are fabulous, but fraction can also be used turned to decimals. How do we turn a fraction to a decimal? Divide, exactly. So we would take the top number divided by the bottom number, and that would give us a decimal. So fractions and decimals are going to be the most useful ratios we are going to deal with. I will recommend that you write all of your ratios as fractions to start, and then change them to decimals or even to percents. Right? So this is kind of the fraction, decimal, percent bus that we're all going to drive as we go through this section. Okay, so that's kind of the intro to ratios. I forgot to erase. There we go. Okay, the real humdinger in this section, if you will, are age dependency ratios. I feel really certain that you, all 12 of you, can watch one video about ratios and go, well, yeah, I can do that. I can write those things as a fraction, change that to a decimal. Heck yeah. All right. This class is like, I always say it's kind of like riding a bike, right? You haven't done it in 5, 10, 15 years. So you get on, you wobble a little bit at first, you oil everything up, and then you're golden. That's what this stuff is, a lot of this stuff is going to be. You're going to be like, man, I saw that, but it was 18 years ago. Great. You knock the dust off, you work a little bit, a little rusty, and all of a sudden you're flying. So I think ratios is a section that you're going to knock the dust off. It's going to take you a few minutes, and then you're going to be fine. However, the end of the section talks specifically about age dependency ratios. This is an application of ratios. And it talks in terms of the economy, right? Money in the economy, that kind of thing. But because it's not something that we see as normal people, it's a little bit harder to grasp, which is why I want to talk about it in this session. So before we get into the mathematics behind the age dependency ratios, I want to just talk about in terms of children, right? Because when you have kids, kids are dependents, right? You feed them, clothe them, you put a roof over their head, blah, 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 blah. Great. Okay, so I have a job, as we know. I'm doing it right now. I am single. I have no children. I have no pets, right? When I go home, my house is empty. I do have an occasional spider that, I dance around before I kill it with two tissues or suck it up my vacuum cleaner. But I don't pay for that spider, right? I kill it. So I have no dependents. When I get home, it's just me. When I go grocery shopping, it's just for me. When I go clothes shopping, it's just for me. So my money, I can spend it stupidly if I want because I'm only providing for myself, right? Then I've got the person who teaches next door to me. She's married. She has 2 kids. And I think they have a cat. Okay, so when she goes grocery shopping, she's buying for 4 people and a cat. When she goes clothes shopping, she's shopping for 4 people and a cat. Well, she probably didn't put clothes on her cat, but that would be cool if she did. Okay, so anyway, her money doesn't stretch as far, right? She has less free money because she's got all of these dependents, right? The money suckers, the fun suckers, the kids. Kids are great. But that's kind of where it lies, right? We're talking about dependency ratios. If you have less people dependent on you, you have more free money. That's the whole economy. That's the econ part of this. All right. Does that make sense? I don't know. I feel now like I'm babbling a little bit. Okay. So here's the deal. Child dependency talks about the ratio of children to whom they are dependent upon. By definition, children run between the ages of 0 and 14. I don't know why it's only 14, but when you hit 15, you officially become part of the working class. And the working class is who is supporting everybody. So the working class is 15 to 64. So when we're talking about child dependency, the ratio is children compared to workers. Now, this is a part-to-part ratio. If you have not watched the video on age dependency ratio or on part-to-part, part-to-whole, you're going to want to do that, right? But it's a part-to-part ratio, meaning we can only write this ratio as a decimal. And we will get to an example where we actually do the math on the next screen, okay? Old people also need somebody to take care of them, right? That's why there's nursing homes all over the place. Old people are 65 and above, which I love it because now I can tell my parents they're old. They don't like it, but they get over it. So old people are anybody 65 and above, and they also depend on the working class. So again, we have a part-to-part ratio. We can only write this as a decimal. And last but not least, we have age dependency, which is all dependents. So we take the children who are 0 to 14, and we add the old people who are older than 65, and we compare that to the working class. So one thing that I want to point out, all 3 of these will be written as decimals because they are all part-to-part ratios. And they are all compared to the working class. Notice that. The denominators for each one is the same. They're all the working class. Those are things that will help you as you're working through homework in section 2. Okay. Questions about the definitions of age dependency ratios. Going once, going twice. By the way, I'm not sure if you guys know this or not, but you have the ability to raise your hand. I think it's next to, on my screen, it's next to the names. It's got a little hand on it. Uh-oh, there you go. I think if you click, somebody click on the hand if you see it. There we go. Thank you. Oh my gosh, look at you people. It means you're paying attention. I love it. So if you have a question, but you don't want me to move on or something, oh, and you all put your hands back down. Good job. And I can put your hands down too. Anyway, you can raise your hand to get my attention in order to, stop. If you're typing a question and, you can raise your hand and then type your question, that works too. I try to monitor that too as much as I can. But okay, anyway. All right, let's do an example. So now we have our age groups. 0 to 14 are children, right? 15 to 64 is the working class. 65 and above are our old people. And we're dealing with pretty small numbers here. Okay, based off of the ratios from the last section, I would like you to just write me fractions for each one of these ratios if you can, based off of the information we just talked about. I'm going to give you about a minute. And if you don't get it, that's fine. We're just chatting to see how we're doing here. Laura, just hold on for 1 second. Okay, child dependency. So yes, Laura, now you can type one in there. What is the ratio, the fraction for child dependency? Oh, dang, look at you guys already having them typed in so you can just hit enter. That's impressive. Okay, so we've got 400 over 850, 220 over 850, and Tiffany, your last one is incorrect. But Laura's got it. Yeah, you're going to add the 400 and the 200 together, or the 220 together over 850, which gives us 620 over 850. Not sure where you got 620. Yeah, there we go. Okay. Questions about how we got any of those? Right? Child dependency is the children over the workers, old people over the workers, and the last one we add all of the dependents. Okay, your next job, change those 3 fractions into decimals. Round to 3 decimal places. Now we're going to check our rounding skills. So round to 3 decimal places. If you have questions, you got to speak up or raise your hand or do something. And you can go ahead and type them in the chat box as soon as you have them. 3 decimal places. Brittany, what's up? Should you be able to do this without a calculator? Well, you could, but I certainly would never want to. I would definitely be using a calculator. Yeah. Realistically, this entire class, that's a lie. I mean, I guess you could do the entire class without a calculator, but your life is going to be hell if you try to. Because we're going to deal with a lot of really big fractions that we're going to change to decimals. So yeah, you definitely want a calculator. Um, and you can use any calculator you want. On the exam, you cannot use your cell phone as a calculator. So you will need an actual physical calculator when you go in to take the exam. So, all right, good. Good use of the raised hand feature. I love it. Okay, so we have decimals, and it does look that we rounded correctly, which is always a positive. 471 here, 259 there, and 729 here. I forgot the 0 here. Okay. Good, good, good. Now I want to go a little further with this because this is my job. First things first, sometimes WebWork can be a little dirty piece of trash, and you will need a 0 in front of your decimals. So if you forget and you just type in 0.471 and it says wrong, like you might need a 0 in front of that. So double check that, just to keep that in mind. But one thing that we need to talk about is the interpretation of these ratios. Okay, so what I'm going to do is we're going to deal with the age dependency ratio, but I'm going to erase this so I have a little bit of room. So our age dependency ratio was 729. Now, I can make anything a fraction by putting it over 1, right? I don't think anybody's going to argue with that so far. But here's the deal. What this means, we know that the numerator is dependence, right? The children and the old people. So the top number represents dependence. The bottom number is workers. So 0.729 dependents, people depend on every one worker. And to me, that doesn't make any sense. You can't have 0.729 of a person. So it doesn't make sense to say 0.729 people depend on each worker. Doesn't work. So mathematically, if we multiply the numerator and the denominator both by 10, right? 1 0 means our decimal is moving over one spot. That's what multiplying by 10 is essentially doing. That now gives me 7.29 over 10. So now I can say there are 7 dependents on every 10 workers. Well, that makes more sense, right? If there are 10 people in a room, they are supporting themselves and 7 more people. We can all picture 17 people in a room. That's easier. We can even go further. We can multiply again by 10 or by 100 in the first piece, and that gives me 72.9 over 100. So if I round, I could now say there are 73 dependents on every 100 workers, right? Or, just for fun, let's go one more decimal place, and now I have 729 dependents on every 1,000 workers. So simply by manipulating our fractions, we also call this equivalent fractions because they all have the same value. They're just written with different denominators. So by doing that, we allow this to have a different visual. If you picture 1,000 people all working, they're supporting themselves and 729 more people. So they're pooling their money together to support these people. Okay, so now thinking back to earlier conversation about kids and them being expensive, generally we want our age dependency ratio to be low. Because think about it, the less people you have to support, the more money you have, the more money free in the economy, right? I buy shoes. Well, I used to buy shoes all the time. I've tried to cut back because I had extra money and I love shoes. Whereas my sister, who has 2 kids and 3 dogs, they don't have much extra money. So I usually give her my hand-me-down shoes. I have more free money because I have less dependence. That's the same kind of idea. So we want a low dependency ratio because then there's more free money in the economy, and we know that that makes just the world go round. Okay, I'm done yapping about that. Any questions about section 2, which is ratios, age dependency ratios, anything like that? This is the highlight, right? This section, I usually teach it in 2 hours in a face-to-face class. We just did the whole thing in 39 minutes, and that includes the intro to the class. So give me a high five is what I'm saying. All right, any other questions? Got no hands up. Okay, so this is kind of how the class is going to roll, right? So we'll go from here. All right, so that's PowerPoint number 1 for the day. I don't think we need to save that. PowerPoint number 2. And yes, we will always go through, nope, that's a lie. Most weeks we will go through 2 PowerPoints. This is just my reminder to read the announcements because they're important. I generally don't just post things to post things because that's boring. So I post things that I think you'll actually benefit from. So you might want to check out your announcements. Feel free to change your notifications so that you get notices on your phone when I post an announcement. Do you guys know how to change your notifications in Ivy Learn? Maybe I should have opened with that. Does anybody not know how to change their notifications in Ivy Learn? Is anybody still listening to me? Oh, yes. Okay, so people are listening. You don't need the app to do this. Oh, Haley is really listening. Maybe it's because she's got a T on the end of her name. You can change it on a computer. Change your notifications so that you get the announcements with when the announcements are posted. I recommend that if you haven't. If you need help with that, let me know. Okay, moving right along. Here we go. So in Module 2, we have 3 more sections to talk about. We'll go from there. Okay, great. Here we go. I want to make sure I didn't miss anybody. Okay, we're good. Section 3, scientific notation. Scientific notation is something we probably all have seen, but it's probably been a bit, oh, Laura, we don't need that kind of negativity, right? You change that frown and you make it upside down. You got to keep an open mind. You got to open your heart to these numbers and let them in. There's only one way to go, and that's up. So, scientific notation, what do you know? Anything? It's science. Not really. Scientific notation is actually math. Wait, you attempted astronomy and crashed and burned. Oh my gosh, I'm sorry. That was kind of funny the way you wrote that. I took astronomy in college. I fell asleep a few times. It was 8 o'clock in the morning. It was rough. For a very long number, size, hence the Okay, great. You guys are kind of funny. Yes, let's go with Brittany and Tiffany and say yes. Scientific notation refers to the size of numbers. It's generally writing really big numbers or really small numbers. And generally in the field of science is where you deal with these really big or really small numbers. Like the distance from Earth to the moon, big number. The size of an atom, really small number. And so they need a different way to write these numbers to make them a little bit easier to play with. But hey, it's not bad. We're okay. We're okay. So scientific notation, here's the deal. You're going to start with a number, and then you're going to multiply it by 10, and you're going to raise that 10 to another number. Yeah, that's super specific, I know. So the front piece must be between 1 and 10. So basically, when you're looking at a number, the number in front of the decimal, you only can have one non-zero number, right? 4.1 is between 1 and 10. 9.2, one non-zero number, it's between 1 and 10. That's what we're looking for. If you've got 19.2, that is not scientific notation because 19 is not between 1 and 10. Okay. The exponent can either be positive or it can be negative. It's positive when you have big numbers. And now I know what you're saying. What's big? Exactly. That's a really good question. Way to ask it. A big question is anything greater than 10 because 10 is the upper limit here. So if you have a number 10 or greater, that's big. Positive exponent. Negative is when we have a small number, which is less than 1. So if we have a number that starts with a 0, less than 1, we would have a negative exponent. Okay, so that's kind of how we will work through those two pieces. Okay, all right, so there's kind of your beginning piece, and we're going to work through quite a few of these in section 3 and 4 have scientific notation problems. So let's go ahead and do some math because that's where the fun lies. All right, it's no fun listening to me talk. All right, so we're going to start with the first one. We are going to take 320,000 and we are going to convert that to scientific notation. Okay, well, the first things first, you have to decide, is 320,000 big or small? Big, absolutely. I also like to think money. If this is an amount of money you would be okay if somebody gave you legally, then it's a positive exponent, right? If you walked up to me and said, "Hey Becky, I'm going to give you 320,000 for being so good at your job," I'm taking that money, right? So that's positive. We have a positive exponent. Okay, great. Now, where is the decimal right now? If we don't see it, where does it fall? Behind at the end. Very good. Okay, so now we need to change that decimal and we want to make it so there's only one non-zero number in front of it. Okay, so we want to put it here. So I'm going to have 3.2. All non-zero numbers need to be a part of that problem. And then it becomes a counting problem, right? So from where you started at your decimal to that yellow line, 1, 2, 3, 4, 5. I moved it 5 places, so my exponent is a 5. And that's your answer. Done. In the second problem, we have times 10 to the fourth. Now we have scientific notation. We want to change it to standard form. So what does this 4 tell me to do? Move the decimal. Which direction? We want to move it to the right. It's a positive 4, meaning my number has to get bigger. Remember, because positive is big. So to make my number bigger, I have to move it to the right. So 1, 2, 3, 4. And these empty spaces get zeros. So I'm at 17,500. And there is my answer in standard form. All right, you will need to be able to move back and forth between scientific and standard. Okay, 2 questions for you guys to try. First one's a little bit trickier, but let's see what you can do. I'll give you about a minute or so. And do both problems. Tiffany, you got something wrong with your first answer. Yep. Okay, let's go ahead and since most of you are starting to throw things in, I am going to diagram this for our friends at home who are going to watch this later. One thing that is crucial is the word million. And there is a video, if you're not familiar with all the big numbers and how they're represented, there is a video that talks about how the numbers all work together. And so we know million means 6. Billion is 9, trillion is 12, quadrillion is 15, thousand is 3. So this is the same as 43.4 times 10 to the 6th. To me, that's kind of the easy first step. But what's wrong with this picture? Well, 43 is bigger than 10, right? Yeah, so you're looking at this front piece and you're like, that's not scientific notation. Well, bigger than 10 means positive exponent. So if I move my decimal one place so that I get the 4.34, I moved it one place, so that gives me an exponent of positive 1. Well, don't forget, I still have this times 10 to the 6th power in part of my problem. Now, if you remember your exponential rules from back in the day, when you multiply same base, you add your exponents. So you end up with 4.34 times 10 to the 7th. Yep, and there are other ways to do that. Obviously, there are other ways to do that, but that is one of them, right? Which everybody who put their answer in the chat box, that's what you had, so that's good. In problem number 2, our exponent is a 3, which means we're moving 3 places to the right. 1, 2, 3. We add that 0 in the empty hump at the back. And there is our last answer. Any questions about dealing with positive exponents in scientific notation? We will get to negative exponents in about 6 minutes. So again, just a quick refresher, right? We're not spending tons of time on this. There are plenty more videos that go over plenty more examples, including multiplying and dividing with scientific notation. All of that is in the videos that go with your packet built into the modules. Okay, so that was section 3. Now we go into section 4, and we get into per capita. Do any of you know what per capita means? That was a quick no, which is good. I don't really know that I've ever really dealt with per capita until I started teaching this class, so I get it. Okay, one thing that from now on in this class that, Brittany, close but no. The word per, I want you to kind of think of that as the fraction bar. So when you see the word per in a problem, think fraction bar. That way when you're writing your ratio, that's where the fraction bar comes, and your numerator and denominator are split right there. So yeah, Belle got that. Capita is simply another word for person. So when we're talking about per capita, we're talking about per person. So we want to know per person what's happening. So we're taking a fraction bar and we're putting the people on the bottom. And because we want it per one person generally, then we would divide and we would turn it into a decimal. I don't know why I just assumed there'd be a 0 there, but we would turn it into a decimal. Okay. All right, let's look at our second example. We'll do this one together, then I'll cut you loose on one. If there are 240 TVs in my family and 78 family members, how many TVs per capita? So here you go. Here's the problem. Per is the fraction bar. So we're looking at TVs per person. So what number goes on top? 240. Then we have the fraction bar. How many people are we dealing with in this particular problem? 78. Yep. And that ratio in and of itself doesn't tell us a whole lot. But when we talk about per capita, we want to go per one person. So to change that to have a denominator of 1, we simply divide. Right? We want to change that to a decimal. So what is 240 over 78 as a decimal? Let's go 2 decimal places, please. 3.08. Very good. And so we would say there are 3.08 TVs per capita in my family, right? Because again, this can say like we're going over 1, because anything can be made a fraction by putting it over 1. TVs are represented in the numerator, and people are represented in the denominator. So that's the basic idea. Per capita is another thing about ratios, right? So really we're getting into more ratios. Okay, you guys try this one. All right, as the answers come in, let's start chatting. A local pen company produces 23 million blue pens each year. This is made up data. If the population of the town is 540,000, how many blue pens are produced per capita in this town? So per capita, again, we're talking, there's your fraction bar. So we're talking about blue pens over people. So we have 23 million over 540,000. Now, did you just write these numbers out into standard form, or did you change them both to scientific notation? Standard. Okay. I actually want to show you kind of a cheating way, if you will, which is not really scientific notation. It's not really standard. So when I see million, right, I know that million is 6. And I know 23 times, that is not scientific notation. But mathematically, that is the definition of what that number is, right? Million is times 10 to the 6th. And I know that 540,000 is 5.4 times 10 to the 5th. That's real quick for me to do. I don't have to think too hard to see that I would move 5 decimal places to get there. So even though the numerator is not in scientific notation, I can divide this. I can divide 23 divided by 5.4, and that gives me 4.259. My rules of exponents show if I divide, I subtract my exponents. So 6 minus 5 gives me 1. And I want my answer to be in standard form because when we talk about how many blue pens per capita, we talk about that in terms of a number. So if I move my decimal 1 place because of this 1, I end up with the 42.59 blue pens per capita that y'all have put in the chat box. So I really just like to give you additional options. There's multiple ways to do this problem. I want to make sure that you see them, or that you see more than just maybe one way, just in case you find something that you like better. Maybe you think it's easier, save you some time, whatever. But okay, any questions about per capita by definition? Right? It's just taking writing a fraction and then changing it to a decimal is generally the idea. And then understanding what your answer means is also crucial. Okay, great. Brittany, that's another excellent thing. Let me go ahead and shout that out here. So Brittany said she put the zeros out, so there will be 6 zeros here, and then 540,000. And because math is fabulous, as we all agree, the zeros cancel out, and then you're just left with 2,300 divided by 54. And yeah, that is another good option. That makes it a little bit easier. Yeah, good. Okay, I want you guys to try these two. Now we're still talking scientific notation, but now we're dealing with small or negative exponents. So you guys try these real quick. Or take your time. It doesn't have to be quick. All right, bunch of good answers coming in. So on the top one, you remember you want your decimal point to be one non-zero number in the front. This is a pretty color. And this is a small number, right? Think about money. If somebody offered you that kind of money, that's not even a penny, right? Why are you slapping me in the face? So no, it's negative. So we go 1, 2, 3, 4, 5, 6. So 10 to the negative 6th. And then in the bottom problem, because your answer is negative, your number is getting smaller. To go smaller, we go to the left 3 places. Don't forget your decimal point. I have a lot of people who they'll add the zeros in the front but forget the decimal point. And remember, WebWork prefers a 0 in front of the decimal point. So, good. Any questions? Section 4, per capita in negative scientific notation. Okay. In that case, we're off to the last section of the day, which is proportions. And yeah, solving proportions is usually not the issue. It's the setting up of proportions that drives people nuts. So first, we're going to talk about solving. Do any of you remember from your past life how to solve a proportion? Cross multiply. Yeah, very good. So let's diagram that so we know exactly what that means. So when you cross multiply, it means you're going to take the denominator of one ratio and multiply by the numerator of the other. So 12 times 2 gives me 24. Then the equal sign comes down, and then you take the denominator, multiply by the other numerator, and 3 times x is just 3x. So you've now created an equation. Laura, you got a slight issue there. How then do we get x by itself? Mathematically, what do? You divide by 3. Whatever is in front of the x is what you divide by. So x equals 8. So every proportion we do is solved by cross multiplication, right? And we're going to use that a lot. We use proportions like they're introduced here in section 5, and we're going to use them in like, I don't know, 8 more sections after this. So you're going to get really good at solving proportions. Well, I hope you get really good at solving proportions. Okay, so setting up proportions is kind of the key. And I'm a huge fan of labeling. So let me show you what that means. There are multiple ways to set up every proportion. When I say multiple, I mean like 16 or 8 or a ton, right? A lot. There are a lot of ways. And it doesn't matter which way you choose as long as you are consistent. And what I mean by that is when you cross multiply. So if all 13 of us here today set up the proportion differently, when we cross multiply, our equation should look the same. And as long as our cross multiplication is the same, that means our proportion is consistent. I label my proportions because then I know I'm not going to make a silly mistake and put a number in the wrong spot. So let's look at this example. Sally ran 4 miles to every 3 miles run by Billy. If Billy ran 254 miles in 2016, how many miles did Sally run? Okay, so I can see by looking that I'm comparing Sally and Billy. And as soon as I know that I have a comparison piece, a proportion is all about a comparison. We are comparing one ratio to another. That is a proportion. So I'm comparing Sally and Billy, and I have kind of their scale, I guess, if you will, and I have 2016. I don't always have labels for all 4 spots, but sometimes I do. So now when I look at this, my numerator is all about Sally, right? We've got Sally on the scale, we've got Sally in 2016. The denominators are all about Billy, the scale, and the 2016. So when I go back and I read the first sentence, Sally ran 4 miles to every 3 miles run by Billy. That's the scale. Sally did 4, Billy did 3. Then I go to the next sentence. If Billy ran 254, well, Billy's on the bottom, so 254 goes here. How many did Sally run? I don't know. And now I have the setup. And again, there's multiple ways to set this up, and that's fine, as long as when you cross multiply, you get 3x, my equal sign comes down, and then 4 times 254, which is 1016. And then we change color for effect, and we divide by 3, and we are left with 338.7 or 67, that's fine. And that is miles. Yeah, and I recommend writing the steps down. I know everybody wants to hold their calculator in one hand and then type the answers in the other hand, and you never want to pick up a pencil. But I'm telling you, if you will take the extra 15 seconds to write your problems down and work them out on paper in conjunction with your calculator, you will make less mistakes. When it comes to exams, you will be provided scrap paper when you go to take exams. And you turn that scrap paper into the proctor, and the proctor emails me the scrap paper. And then when I grade your exam, because your scores will look horrible when you're done. You can get a 98% on an exam, but when you first turn it, it'll say like 35% because I have to do a lot of grading in those, and there's a lot of things that don't calculate correctly. Anyway, I always have your scrap paper up when I do this. And every semester, I'll have students who I'm looking at their scrap paper and I'm like, wow, that is impressive. Like it's beautiful. It's every problem. And I don't need it because they get every problem right. It seems like the people who really show their work and do things on paper first, you know, they do well. So I just want to encourage you that even though some of these can be very easy to just type them into your calculator, resist the urge and actually write things down on paper. So, Kristen, I'll be posting an announcement as soon as I get the paperwork into the proctor sites at Ivy Tech. I will submit information on how to schedule the exam with Ivy Tech. But yes, you need to schedule it at least 24 hours before you want to take it. So if you want to take it on Tuesday, you can't try to do it Tuesday morning. It doesn't work that way. So yeah, but I will be getting that announcement out within the next couple of days. Because I highly recommend you schedule early so that you get the day and time you want. Yep. So keep an eye out for that here coming up. Okay, I want you guys to try this proportion. No, Brittany, you can take it at the Elkhart campus. Yeah, you can take it at any Ivy Tech in the entire state. All right, answers are starting to come in. That's great. All right, so let's look at how we could set this up. And again, you guys might have set this up completely differently, but you read it and you're looking. Cleveland to Columbus is 140 miles, just 1.5 inches on the map. DC to Pittsburgh is 5.5. How many miles? Okay, so I'm talking about two different trips. Cleveland to Columbus, DC to Pittsburgh. And we're talking about miles in inches, right? So those are my labels. And if you are a visual person, labeling things throughout this course could be very helpful for you. Okay, so then we go back. It's 140 miles from Cleveland to Columbus. It's 1.5 inches. DC to Pittsburgh, 5.5 inches. Inches are on the bottom, so the 5.5 goes on the bottom, X on the top. We cross multiply, as you all have said, 513.3 miles to DC to Pittsburgh. Okay. All right. Questions on that one? And if you set it up differently, totally fine. You should still have gotten 1.5x equals 770 when you cross multiplied. As long as that was your cross multiplication equation, you're golden. Golden. Questions on that particular proportion?
No, that's easy.
Yeah, good.
This class is easy as fuck.
Can you watch your language, please? Thank you. Okay. Let's go ahead and move on to the next question. Now we're going to play the what if game with proportions. You'll notice that we're talking about a made up problem here of Michigan and Ohio, where each has raised the money with a particular number of people. So you might be thinking, how can I write a proportion with that? Because a proportion generally, there are 4 pieces in a proportion, and one of them is an unknown value, right? But we have all 4 pieces. So the question here, if Michigan were proportional to Ohio, how much money would Michigan raise? So the question is kind of an expected value of, well, oh, it's okay. You weren't muted, but I did mute you. Okay, so now we are comparing Ohio to Michigan. And when you're doing the what if game, it's very, I think you should at least put this out. We're talking about money to people. I always start with my unknown. So when you're checking this out, how much money would Michigan raise? If Michigan was as good as Ohio, what would they do? So we're trying to find the money that Michigan would raise if they were like Ohio. So the other 3 pieces come from this information up top. So Ohio raised $24,750 with 300 people. Michigan had 250 people. And now this green value is the expected. We often call that the expected value. So this is expected, whereas the 1650 is the actual. And then we can have a conversation comparing the two. I'm assuming you guys are doing the math. Yeah, very good. Okay, so if Michigan raised money like Ohio, they should have raised $20,625. But they only actually did 16.5. So you'd say if Michigan were proportional to Ohio, they would have raised $4,125 more than if what they actually did. And that's how you can play the what if game. You find their expected value, then you can compare it back to what they actually did and say, well, obviously Ohio raised more because Michigan would need an extra 41.25 in order to be like them. Okay. Questions about proportions, the what if game. There are a couple videos that deal with the what if and types of proportions that might be beneficial if you need a little bit more help with that. But any other questions? Going once? Gone twice? All right, well, we are done a little early today, but that's not a bad thing either. Thank you, Aurora, for doing that sold there. That's great. So remember, I'll be posting an announcement either later this week or early next week about how to schedule an exam with Ivy Tech, any campus of Ivy Tech. If you know already you will not be taking a test at an Ivy Tech campus, I need you to email me that as soon as possible so we can move forward on that one. If you have any other questions, WebWork, anything, shoot me an email. I'll get back to you as soon as possible, and we'll go from there. This recording will be posted under the announcement section under live session 6, since today is the 6th. That way, if you need to reference anything that we talked about, you can do that too. That's great. Okay, one other thing I need to talk about real quick before we're done for today is that 2 weeks from today, okay, so next week we're covering modules 3 and 4, which would be the rest of Unit 1. And then on the what is 2 weeks from today? The 20th? My gosh, I'm losing my mind. Yep, the 20th. The 20th of June, I will be on a plane going to Texas on Wednesday. So I will be unavailable for our live session. Now, we have an option. One of our options is I teach the same class on Tuesday from 12:30 to 2:30. So if you would like to be a part of that session, I can send you the link and you'd have to register for that class so that you can come to the Tuesday session. or I can just take the Tuesday session recording and post that in the Wednesday class, and you can watch it at your leisure whenever you would like. Do you have a preference? Or we could pick a different time, and I could do it. At anything else. Okay, so it's looking like just post the recording. Perfect. Yep. So they're on the same thing. If you want to be a part of the live session on Tuesday, send me an email and I will send you the link individually, because I don't want to confuse people with sending out a whole new link if you don't want it. So if you want the link, shoot me an email. Otherwise, I will definitely post the recording in the announcements so that you can see what's happening. But that is exam week. So there's only, there's a little bit, there will be a couple sections that we'll talk about, but you are going to need to be taking your exam that next week. So we'll talk about that next week as well. But okay, so that's the 20th, 2 weeks ahead. Next week, I will be here normal time, same bad channel. We'll get this thing done. So good. Okay, great. Does anybody have any other questions? If you don't have any questions, I'm done. So feel free to peace out. Go forth and prosper. Do some math. Remember, due dates on stuff is Friday and then next Monday. And yeah, I'll stick around if you have questions, but otherwise, I'll see you next week.